Hi everyone, I'm Chuang Tan from Beijing Jiaotong University in China. It's my pleasure to make a presentation here to introduce our work on the field Weakly-supervised Object Localization. And the title of our work is the Dual Gradients Localization Framework for WSOL. This project is a joint collaborative work between BJTU and YSU. Before we dive into the details, let me introduce the definition of Weakly-supervised object localization. WSOL is understanding an image at the pixel level, only using image level annotations. Compared with full supervised object localization, WSOL uses much cheaper annotations to learn information of object locations. Recently, most of WSOL works achieve localization by two steps, like SPG, ACL, and ADL. Firstly, they force classification network to focus on more regions of feature maps. Then they produce localization map on the last convolutional layer by applying CAM. However, two issues exist in recently WSOL approaches. Firstly, they ignore the localization ability of other layers. The localization map can only be produced on the last convolutional layer, which limits the scope for searching the best locations. Secondly, both classification and localization tasks are trained online based on a single classification model, so it's difficult to obtain an optimal model for both tasks by using only image-level labels. To solve aforementioned problems, we propose a new approach named the Dual Gradients Localization Framework. Our main idea is to achieve localization on any convolutional layer of a classification model by exploring two kinds of gradients. Firstly, we utilize gradients of classification loss function to main intertarget object regions. Secondly, we leverage gradients of target class to identify the correlation ratio of the pixels to the target class. This is the entire framework of DJL. It consists of three key modules: classification model, class-aware enhanced map branch, pixel-level selection branch. In particular, only classification model will be trained for classification tasks. Class-aware enhanced map branch and the pixel-level selection branch are offline operations. I will give the detail of the three key modules among this framework in the following. SPG plane is adopted as a backbone network, which is a customized inception method. We remove the layer after the second inception block. Then add two convolutional layers, a GPA layer, and a softmax layer. A contradiction puzzles WSOL that the classification task tends to recognize the most discrimination regions of objects, while localization tasks tend to localize the entire objects on the single scene model. CAM performed on scene model is only trained for classification, resulting in only discover the discriminative regions. We believe that the feature maps predicted to class C only capture the discrimination path of objects when the feature map closes the boundary of classification regions. And the feature map located at the center of the classification regions can highlight more object regions. So in class-aware enhanced map branch, our key idea is pulling the feature maps towards inside a classification region for a specific class, along with gradients of classification loss function. In pixel-level selection branch, we investigate the CAM from a new view, that's gradients view. We believe that CAM actually achieves localization by employing a weighted sum of feature maps, and the gradients of The target class on the last convolutional layer instead of the weight of the final FC layer. In this way, any convolutional layer in classification model can be employed for produce localization map. Note that the pixel level selection is a generation toolcam. Here is the results of DGL framework on the radiation side of LID dataset. We fusion the localization map of branch 1 and branch 2 on mix the 6A layer, and the input size is 324. During inference, we apply multi-scale inputs and macros. We achieve 62.22% in terms of LU. Here I present some visualized results generated by our DGL, which proves the high accuracy of our methods. Welcome to contact us to discuss more details. Thanks.